Welcome to Algebra 1, Chapter 4, Section 2, Patterns in Linear Functions. The vocab word we need to consider is independent. An independent variable is a variable whose value determines the value of another variable called the dependent variable. In math, the independent variable is the variable we put into our function or into our equation to get our solution. So for example, if we have equation y equals 2x, and we allow x to equal 1. Well, when we put this 1 into the x spot, we get y equals 2 times 1, and that gives us our y value of 2, which is our dependent variable. So the independent variable is often the input, whereas the solution we get is considered our output. Using this vocabulary word of independent, let's look at some options. We are going to determine if the first part of the sentence is independent or dependent of the second part. So is the growth of the plant independent of the light it receives or dependent on the light it receives? Well, since science has proven that plants grow better with more light, it is dependent. Is the speed of a swimmer independent of the depth of a pool or dependent on the depth of the pool? Well, unless the pool is extremely shallow, it does not matter how deep the pool is. The speed of the swimmer should remain the same. So those are independent. The number of books a shelf holds, is that independent of the length of the shelf or dependent on the length of the shelf? Well, it is dependent. The longer the shelf, the more books that could possibly be held. So a dependent variable changes its response to another variable, the independent variable. Once again, here's an example. The length of a shadow depends on the time of day. So the time of day is independent, but the shadow is dependent. Values of independent variables are called inputs. Values of dependent variables are called outputs. You will see our inputs, we often call them X in math, and our outputs are called Y in many equations. When each input value has exactly one output value, that is called a function. Again, for a function to exist, each input value must output a single value. Here are three relationships. Two of these are functions, one is not. Now, a function is where an input value has only one output value attached to it. Each input value has only one output value attached to it. Here we have an input value that goes to two different output values. So this cannot be a function. These are both functions. Each input value has only one output value. A linear function is a specific type of function whose graph is a straight non-vertical line. And you're going to see this as y equals mx plus b. B will be the y-intercept, and m will be the slope. In a linear function, the values of the dependent variable is y, changed by a constant amount, that's the slope, often referred to as m, as the independent variable, x, changes by a constant amount. Now if that's confusing, it's okay. We're going to expand on this quite a bit in this chapter. Let's try a problem. In these diagrams, we have a relationship between the number of triangles and the perimeter. So our number of triangles are going to be the x. This is our x. And the perimeter is our y. So this is our y. So if we have one triangle here, we have a perimeter of 10. When we have two triangles here, we have a perimeter of 14. When we have three triangles, we have a perimeter of 18. And we have four triangles, we have a perimeter of 22. So we find the perimeter is 4 times the number of triangles plus 6. And we'll talk in class about how I got this plus 6 value. So our perimeter, y, is equal to 4 times, what was the number of triangles? Oh yes, it was x, because our perimeter is y, plus 6. So that's our equation. On the previous slide, you saw that y equals 4x plus 6. We will use that to plot. So what we're going to do is notice here we have 1 equals x. So we're going to put that in our x spot. Here's our x spot, so we're going to put a 1 there. 4 plus 6 is 10. So this creates the point 110. As we plot the point 110, right here. For the next value, we have 2. Put the 2 in for the x. 4 times 2 is 8. 8 plus 6 is 14. So that gives our next point as 214. Plot that as well. Our third point has an x value of 3. So we'll put that in the x spot. 4 times 3 is 12. 12 plus 6 is 18. So that creates the point 18. And then we have our x value of 4. So we put 4 in the x spot. And we said it equals 22, which creates the point 4, 22. And as you can see, this creates a line. It's a linear function. Straight line means it's a function. So let's decide if this table represents a function. Now to be a function, each x can only go to one y. As you can see, 0 only goes to 1. 1 only goes to 3. 2 only goes to 5. 3 only goes to 7. So yes, this is a function. Each x only goes to one y. Now, creating an equation is a little tricky, and we'll practice this. I have a game in class we'll practice this with. But to create an equation, you want to find the change in y. How much is y changing each time? And you're going to put that over the change in x. So in this case, the change is 2 over 1. And that's called our slope, our m. Now, all linear functions have the equation of y equals mx plus b. Write this down here. Y equals mx plus b. All functions that are a straight line have this equation. Our slope is this down here. This is 2. So we're going to have the slope of 2. And then the b part is it's called a y-intercept, which means where it changes, or where it crosses the y-axis. So when we plot this, we see the first point is right here at 0, 1. Well, obviously, that's where it crosses the y-axis because it's right there. So it crosses the y-axis at 1. Our next point is 1, 3, and 2, 5, etc. So here's our line. Let's take a look at this one. Again, we want to know if it's a function. Yes, it's a function. Each variable of x only goes to one y. Y-intercept. Whoops, sorry about that. Let's go ahead and try another one. Again, we have this table here, and it again is a function because there's a one-to-one relationship here. So yes, it's a function. Each x only goes to one y. But we need to write the equation. Now remember, our equation is y equals mx plus b. So to write an equation, we need our m and our b. Our b is where it crosses the y-axis. So this is our b. So our b is going to be 512. Because I know I'm going to plot that point, and that point is going to be right here at 512. So 509, 506, 503. And we're going to skip some numbers here. Okay, so to find our slope, we need to look at the difference in our y's and our difference in our x's. So we're going to look at our difference. X's are easy. They're all 1. But our y's are going down by 3. So again, our slope is our change in our y over our change in our x. Our change in our rise over run. So our slope is negative 3 over 1. We got that from negative 3 over 1. So as I write the slope up here, I'm going to write negative 3 over 1. So that's my equation. And that tells me that as I plot these points, we go this way. But look at this line goes downhill. That's because it has a negative slope. Whoops, because I can't spell that. It goes downhill. Here's another problem for us to try. Wants to know if this relationship in this table is a linear function. I would like you to pause this video for a few minutes, try this, and then come back and see how you did. Okay, is it a linear function? Well, we look at our change. Here's a change of 1, change of 1, change of 1, change of 2, change of 2, change of 2. It is a constant change. And our y over our x, our slope, is 2 over 1. And where is the y-intercept? Where does it cross the point? Well, it crosses the point at this point here, 0, 8. So that's our y-intercept. So our m equals 2, and our y-intercept equals 8. So our equation, y equals mx plus b, becomes y equals 2 for our m and 8 for our b. So this is our equation. We could have also put these points into each of these equations to see which one worked, but once you get the hang of my way, it's a little easier. Let's plot some points. 0, 8, that's our y-intercept. 1, 10, 2, 12, 14, and we have our linear. So the points do lie on a line, and it is a linear function. Sometimes you're given points, and you have to plot the points to see if it's a linear function. Now, linear means line, so if it's a linear function, it'll be a straight line. And we plot those points. Do they represent a linear function? No. They do not lie on a straight line. That's it. I'll see you in class tomorrow.